Here, we will be dealing with volume of right circular cone, sphere and hemisphere. Let us take a right circular cylinder and a right circular cone of the same base radius and the same height. Try to make a hollow cylinder and a hollow cone like this with the same base radius and the same height. Then, we can try out an experiment that will help us to see practically what the volume of a right circular cone would be. So, let us start like this. Fill the cone up to the brim with sand once and empty it into the cylinder. We find that it fills up only a part of the cylinder in the first figure. When we fill up the cone again to the brim and empty it into the cylinder, we see that the cylinder is still not full in the second figure. Now, when the cone is filled up for the third time and emptied into the cylinder, it can be seen that the cylinder is full to the brim in the third figure. With this, we come to the conclusion that 3 times the volume of a cone makes up the volume of a cylinder, which has the same base radius and the same height as the cone, which means that the volume of the cone is 1/3 the volume of the cylinder. Therefore, the volume of the cone is equal to 1/3 of pi r square h, which is equal to 1/3 pi r square h. Now, let us consider a problem regarding the same. A right triangle ABC with sides 5 cm, 12 cm and 13 cm is revolved about the side 12 cm. Find the volume of the solid so obtained. The solution is as follows. Let ABC be a right angle triangle at B. 13 cm would be the hypotenuse as that is the longest side in the triangle. Therefore, AC is equal to 13 cm, AB is 12 cm and BC is 5 cm. Solid so obtained is a cone with R which is equal to 5 cm and H is equal to 12 cm. Therefore, the volume is given by 1/3 pi r square h. Substituting the values, we get 1/3 into pi into 5 into 5 into 12, giving you 100 pi centimeter cube. Here, our objective is to find the volume of this particular spherical ball. Let us conduct an experiment. For this, we have taken a beaker completely filled with water and a ball of a particular radii. We place this beaker in a trough. Now, I'm going to put the ball inside the beaker. As soon as you put the ball inside the beaker, you see certain amount of water from the container will overflow into the trough in which it is kept. Let us carefully pour this water from the trough to a measuring beaker. So, can we conclude that the extra water what we have collected is the weight of the spherical ball? Yes. Repeat the experiment with a ball of different radii. Once again, this value is nearly equal to the measure of the volume of the water displaced by the sphere. What does this tell us? We know that the volume of the sphere is the same as the measure of the volume of the water displaced by it. By doing this experiment repeatedly with spheres of varying radii, we are getting the same result, namely, the volume of a sphere is equal to 4/3 pi times the cube of its radius. Therefore, volume of the sphere is equal to 4/3 pi r cube. Now, let us consider a problem regarding the same. The diameter of a metallic ball is 4.2 cm. What is the mass of the ball if the density of the metal is 8.9 grams per centimeter cube? Solution is as follows. Diameter of the ball is equal to 4.2 meter. From this, we can find the radius, that is diameter divided by 2, giving you 4.2 divided by 2, that is 2.1 meter. We know that mass is density into volume, that is 8.9 into volume. Therefore, the volume of the metallic ball is given by 4/3 pi r cube, which is equal to 4/3 pi r cube, and r cube can be written as 2.1 into 2.1 into 2.1. Solving the same, we get it as 12.35 pi. Now, finding the mass, we get mass is equal to 8.9 into volume, which is equal to 8.9 into 12.35 pi. Therefore, the mass is 345.44 grams. Also, can we say that the volume of the hemisphere is exactly the half of volume of sphere? Yes, half of 4 by 3 pi r cube gives you 2 by 3 pi r cube. Therefore, volume of hemisphere is equal to 2 by 3 pi r cube. Let us solve a problem based on that formula. A dome of a building is in the form of a hemisphere. From inside, it was whitewashed at the cost of Rs 498.96. If the cost of whitewashing is Rs 2 per square meter, find the inside surface area of the dome and volume of the air inside the dome. The solution is as follows. So the first subpart is that inside surface area of the dome is to be found. That is, area whitewashed into cost of whitewash is equal to total cost. Therefore, area whitewashed into 2 is equal to 498.96. From this, we find area whitewashed is 249.48 meters square. Area of whitewashed is curved surface area of hemisphere, as only walls are whitewashed, not floor. Therefore, inner surface area of dome is 249.48 meters square. The second subpart, volume of air inside dome is equal to volume of hemisphere, that is 2 by 3 pi r cube. Therefore, the surface area of the dome from the question is 249.48 meters square. That is 2 pi r square is equal to 249.48. Now, let us substitute the values. Substituting the same, we get 2 into 22 divided by 7 into r square, which is equal to 249.48. Solving for r square, we get r square is equal to 249.48 into 7, divide the whole by 2 into 22. Therefore, r is equal to 6.3 meter. Volume of the air inside the dome is given by 2 by 3 pi r cube, which is equal to 2 into 22 divided by 7 into 6.3 cube, giving you 523.9 meter cube. Now, let us summarize. Volume of the cone is 1/3 of pi r square h. Volume of the sphere is 4/3 of pi r cube. And volume of the hemisphere is equal to 2/3 of pi r cube.